Okay, today we're going to do lesson 24, and your I can statement or learning objective is I can simplify radicals. So we're just going to practice simplifying radicals today. This is something that should be at least somewhat familiar to you, hopefully. In Algebra 1, you should have done some radical simplification, and then I think you have to do some in geometry too. So hopefully it's not brand new information to you, but even if it is, I'll show you how to do it, and I think that you guys will catch on very quickly. So first, we need to know that this is a radical, okay? And if you don't see a number in the little valley, it's an understood 2, which means it's a square root. Okay, and then we can take square roots of perfect squares. We should know that when you take the square root of a perfect square, you get a whole number. Okay, square roots of perfect squares are rational. You get a nice whole number. So I recommend that you know the square roots of the first 15 perfect squares. So the perfect squares are the numbers inside, like 1, 4, 9, 16, 25, 36, etc., etc. And it's helpful if you just know the first 15 and you have those memorized and you just know them really quickly. However, if you don't know them, that's fine. You can always type them in the calculator. But they can be helpful if you just know them. Now, moving on to simplifying radicals. When we simplify a number that's not a perfect square, you get a long decimal that doesn't repeat, there's not a pattern, it just goes on and on forever. And since you get a long non-repeating decimal when you take the square root of a non-perfect square, we need a way to have an exact answer. We don't want to have to round and have rounding errors. We want to have an exact answer. So that's where simplifying radicals comes in. You can really simplify radicals two ways. You can look for the biggest perfect square that goes into the number and factor it out, or you can just do a factor tree. I'm going to show you both ways. Sometimes it's really, really easy to see what the biggest perfect square is that goes into the number. And so sometimes it's really, really easy to pull out the perfect squares. However, sometimes those aren't as easy to see, so a factor tree is super helpful. So I'm going to show you how to do it both ways. You'll get the same answer, and then you can choose to do it whichever way is best for you. And then you might have to do a combination of both. Some of them might be really easy and you want to do the perfect squares. Some of them might be more difficult and you want to use the factor tree. It's really going to be up to you. Okay, so I'm going to show you how to simplify the square root of 24 both ways. So if I'm going to do it using perfect squares, I'm going to think about the perfect squares and the biggest one that can go into 24. So I know that the square root of 4, I know that that's going to go into 24. So I'm going to break this up into the square root of 4, and 4 times 6 is what gives me 24. So I'm going to break it into these two radicals. The square root of 4 I know is 2. The square root of 6 can't be simplified, so we bring it down, and that's our final answer. Okay, with a factor tree, you can just pick any factors of 24. I know 2 and 12. Okay, 12 can be broken down smaller. I can say 2 times 6, and then 6 is 2 times 3, and then I can't break that down any farther unless I use ones, and I don't really want to use ones. So when you use the factor tree, you're looking for pairs. All right, so since we're doing a square root, we're going to be looking for pairs in this group. So anything that we can pair up. So you're looking at like the edges of the branches. So here I have 2 2s, so that's a pair. So I'm going to pull that out of the house. Okay, if they have a buddy, they can leave. If they don't, they have to stay in the house. Okay, so I have a 2 and a 3 left over, so I'm going to put those in the house. So 2 times 3, I know 2 times 3 is 6. And so that's my answer. Okay, so perfect squares, if you see the biggest perfect square, you can pull it out and simplify that way. If you're not sure, or you just like the factor tree better, do your little factors until you go as far as you can. Find pairs of the same number. They can go on the outside, All right, things that are left over have to stay on the inside and be multiplied together. Now, we're just going to use this to do some examples together. Okay, so let's look at the square root of 50. This one, I can see a perfect square pretty easily. I know that 50 is made up of 25 and 2. I know the square root of 25 is 5, and the square root of 2 stays. Okay, now 60, a perfect square doesn't pop out at me, so I'm going to do 2 times 30, and then I'm going to say 2 times 15, and then 15 is 3 times 5. Okay, so I'm going to look for pairs. So I've got 2 2's. So that means 2 can go on the outside. 3 and 5 don't have a pair, so I'm just going to put those back together inside. So 3 times 5 is 15, and that's my answer. All right, the square root of 120. I can't think of a perfect square right off the bat, so I'll say 2 and 60, and then 60 is 2 and 30. 30 is 5 and 6. 6 is 2 and 3. Okay, so I'm going to look for pairs. So here I have a pair of 2's, and then I have a 5, a 2, and a 3. None of those have a pair, so I'm going to bring 2 on the outside. On the inside, I'm going to have 5 times 2 times 3. So 5 times 2 is 10. 10 times 3 is 30. So 2 square root of 30. And then the square root of 12. Ooh, I know a perfect square right off the top of my head. It's 4. So square root of 4 times the square root of 3. I know the square root of 4 is 2. So I have 2 square root of 3. Okay, so we're really just deciding which method works best for you, and you're just doing that same thing over and over again. Okay, these problems are just a little bit different. You have a coefficient out in front. You have this constant. And so you're still going to simplify your radical. You're just going to bring that constant down at the end and multiply with whatever else is on the outside of the radical. Okay, so number 5. So let's look at this. So we have 288. Right off the bat, I'm not thinking of any perfect squares. You might see one, but right off the bat, I don't see one. And so let's break it up. So 2 times 144. Oh, there would have been my perfect square. So if you want to, if you start doing a tree and you find a perfect square, you can stop and you can just do the square root of 2 and the square root of 144. So the square root of 144 is 12. We bring down our square root of 2. You have to bring down this negative 4. You're going to multiply those coefficients together. So negative 4 times 12 is negative 48. Bring down the square root of 2. Okay. Number 6, I forgot. I should have used my pink pen there so you could see what was my work, but I apologize. Number 6, we're going to do the same thing. So let's break up 20. So I'm going to do this one using a factor tree. So 2 and 10, and then 10 turns into 2 and 5. All right, so I have a pair. So I can bring that out front. I have a 5 left over, so it stays inside. I bring down the 8. 8 times 2 is 16. So we have 16 radical 5. All right, number 7, I have negative 2 times the square root of 100. Oh, what do we know about 100? It's a perfect square. So what's the square root of 100? 10. And we have negative 2. Negative 2 times 10 is negative 20. All right, so we have negative 20. All right, number 8, we have negative 4 times the square root of 80. So let's break up 80. I'm going to say 2 times 40, and then 2 times 20, and then 2 times 10, and 2 times 5. Okay, so let's look. So I have a pair of 2's and another pair of 2's. So this is the first time that's happened. So on the outside, I'm going to have 2 times 2 because this is one pair. This is the second pair. and then inside I'm going to have a 5. So I also need to bring down my -4. So -4 times 2 times 2. So -4 times 2 is -8 times 2 is -16, square root of 5. Now, we're going to talk about imaginary numbers. So we're still going to be simplifying radicals, and you're just going to practice it a lot. The more you do it, the better you'll get. You do that same process every single time, whether you can choose pulling out the perfect square or making a factor tree. Either one will work. But now we have imaginary numbers. So an imaginary number is denoted by this I, or you could see a cursive I, either one. And I comes from the square root of -1. We cannot take the square root of a negative number, which is why these are imaginary. So if you see a negative under the radical inside the square root, you need to automatically realize that's an imaginary number and you're going to have an I. Okay, so we're going to continue practicing simplifying radicals, but now we're going to throw in the negative and pull out the I. Okay. Okay, so we have the square root of -64. Now, I'm going to show you why you can pull an I out, but then you don't have to work that out every single time. So we know we can break a square root up into two parts. So this is the same as the square root of 64 times the square root of -1. We know that the square root of -1 is I, so that's the same as I times the square root of 64. And we know that 64 is a perfect square, so the square root of 64 is 8. So we have 8i. Now, when you write your answers, the I usually comes after a whole number, but before a radical. Okay, so we'll see what it looks like on different problems. All right, and we're just going to work out a few together. Again, we're going to continue simplifying radicals, just get more practice there. All right, so there's a negative in the square root, so I'm going to go ahead and pull out an I. So that gives me I times the square root of 36. I know 36 is a perfect square, so that square root of 36 is 6. So 6i is my answer. Okay, number 3, I see the negative under there. I'm going to go ahead and pull out the I. So I have the square root of 75. I know right off the bat that I have a perfect square that goes into 75. It's 25, and that's 25 times 3. All right, so the square root of 25 is 5. I bring down the square root of 3. I bring the I down 2, so I'm going to have 5i square root of 3. All right, the square root of 27, or a -27, I'm going to pull out the I. I have 27. I'm going to break that one down. 27 is 3 times 9. 9 is 3 times 3. Get your pairs. I have a pair of 3, so the 3 can come on the outside. I still have a 3 left over, so it's on the inside, and I can bring down that I. Okay, let's practice simplifying some more radicals with negatives inside. So I'm going to pull out an I and have the square root of 45. I'm going to break 45 into 9 times 5. 9 turns into 3 times 3. Okay, I have a pair of 3s, so that's going to go on the outside. 5 is left over on the inside, and I'm going to bring down my I. So I have 3i square root of 5. Oh, sorry, I apologize. All right, the next one, I'm going to go ahead and pull out the I, and I have the square root of 88. For 88, I know that's 2 times 44. 44 is 4 times 11. 4 can be broken up into 2 times 2. And 11 is just 1 and 11, so I can't do anything else. All right, so find my pairs. Here I have a pair of 2s. I have a 2 and an 11 left over, so 2 times 11 is 22. And my I is going to come straight down, so 2i square root of 22. All right, number 6, I'm going to pull out the I, and I've got the square root of 20. I'm going to break that up into 2 times 10, and then 2 times 5. I have a pair of 2s, so that goes on the outside. Bring down my I, and then I have the square root of 5 left over. All right, number 7, I have the square root of negative 90. I'll pull out an I, and I have the square root of 90. 90 is 9 times 10. 9 is 3 times 3. And then 10 is 2 times 5. So do I have any pairs? A pair of 3s. So I'll bring 3 to the outside. 2 and 5 are left over, so I'm going to put 10 back inside and bring down my I. So 3I square root of 10. Okay, so let's look at 3 more examples. So this time we have a coefficient out front, and we have a negative on the inside, and we have a radical to simplify. Okay, so on this first one, so I've got a 2. I'm going to leave it out front. I'm going to pull out the I, so I have 2I square root of 45. And we just did the square root of 45 up here. I'm going to do it a little different on this one. So on this one, I know that a perfect square is 9 and 5. So the square root of 9 is 3. Bring down the 5. I'm going to bring down the 2I and multiply. So that's 6I square root of 5. Okay, number 9. I have a negative 8. I'm going to pull the I out, and then I'm left with the square root of 512. Now, I don't know how 512 simplifies right off the top of my head, but I do know that it's divisible by 2. So that's 2 and 256. 256 divided by 2 is 128. Let's see. Let me see if I can find a bigger number. 128 is divisible by 4. So that's 4 times 32. I know 4 is 2 times 2. 32 is 4 times 8. 4 is 2 times 2. And 8 is 2 times 4, which breaks down to 2 times 2. Okay, now, that was a long one. And some of you might have noticed the 256. 256 is a perfect square. So you could have used this method to solve it, but I wanted to show you how it works. You can still do a factor tree, even if it's a large number. You can just keep dividing by 2 or 3, whatever you can get, until you break down all the numbers into the smallest possible set. So let's find some pairs. Here's a pair of 2s. Here's a pair. Here's a pair. And here's a pair, and then there's one left over. So that's 1, 2, 3, 4. So 2 times 2 times 2 times 2, and then I have a 2 left over. So 2 times 2 times 2 times 2, that is 16. Right? No. Oh, wrong. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, yeah, I was right. Sorry. All right. So I have 16 square root of 2. Bring down my negative 8i. I'm going to multiply those together. So negative 8 times 16 is negative 128i square root of 2. Okay, and we have one more. So this time I have just a negative on the outside that's the same as negative 1. I'm going to bring the negative out of the radicals to negative I. And then I have 320. I'm going to break that up into 32 times 10. I know 10 is 2 times 5, and that's as low as that goes. 32 is 2 times 16, and 16 is 4 times 4. And that gives me 2 times 2 and 2 times 2. So let's make some pairs. So here's a pair, here's a pair. That's 2 times 2. I have another 2 left over. Oh, and there's another one. So that's one more pair. And then I have a 5 left over. Okay, and I'm going to bring down my negative I. So 2 times 2 times 2 is 8. So that's negative 8i square root of 5. Okay. Now, I know we've done a lot of examples, but you're going to do the same thing here. You're going to simplify some radicals, and you're going to simplify some radicals that have a negative inside, so you'll have to pull out that I and turn it into an imaginary number. And if you start practicing these and you're having a hard time, you're not sure, you keep getting them wrong, that's okay. It takes a lot of practice sometimes to get really good at these. So it's fine. Just take your time, make as many factor trees as you need to. And if you need help, let me know. I would be happy to assist you. As always, you can hit the Ask My Instructor button, send me an email, whatever you need to do. Have a great day.